Alrighty, welcome to the video lecture on biological macromolecules. In this lecture, we're going to be focusing on four major macromolecules that pretty much make up the majority of life. And when I say macromolecules, I'm talking about big molecules. So remember that there are four, and we'll get into them a little bit later, but real quick, I just want to kind of give you a real quick chemistry lesson. So first off, let's remember that all compounds are matter. All right, and remember that matter is anything that takes up space and has mass. Okay, so if we looked really, really close into matter, if we got down to the smallest unit of matter, what we'd see is an atom. Okay, and you can see right up here, and I have my pen that finally works, so I can kind of draw on this. And let's make it red. So here is our atom, okay, and you can kind of see it looks like a solar system. You have a center, and then you have these things that orbit around it. We call the center a nucleus, and the nucleus contains two types of what we call subatomic particles. So you can see that there's these pluses, and then there's ones that have no symbol at all. The pluses are called protons, and they have a positive charge, and I guess you could say the ones that have absolutely no charge are called neutrons, and they have no charge, and that's why they're called neutrons, because they're neutral. All right? Orbiting around the atom is the electrons, and you can see that they can orbit around at different levels of orbits. All right? And if we looked at even larger atoms, there would be more orbitals going around. So what's important is that in this lecture, all of our compounds, all of our macromolecules are made up of many atoms. All right? And what you need to recognize is they're connected by what we call bonds. All right? And we're going to kind of talk a little bit about bonds in a second. But it's these electrons here that actually help the atoms stick to other atoms and make these large compounds. Okay? So, as you can see right here is the periodic table of elements. If you've never seen this before, it's just a big giant chart of all the different types of atoms that exist on Earth. Okay? So, anything that you were to find that was made of matter would be made of one or more than one of these elements. All right? But there's nothing on Earth that isn't listed on this chart. Okay, so for example, here's just a hydrogen atom, and there's the element hydrogen. Okay. All right. So when we're making macromolecules or compounds or obviously it's composed of more than one atom. All right. So the question is how do atoms kind of connect to each other? All right, how do they make up, compounds that are made of multiple atoms? All right, so what we have is atoms bonding, and basically bonding is just the process of atoms kind of sticking together. Okay, let me get my pen going again. So we have two types of bonds that we're going to talk about at this point. Now, there's a lot more than this, but I just want you to really kind of focus on these two types of bonds. All right. So we have covalent bonds, and we have ionic bonds. Wow, this pen is not working very well. Okay. Now, the difference between the two bonds is just what's going on with the electrons. So these red things that are kind of surrounding the nucleus. All right. So in a covalent bond, the key word here is share. Ooh, that is not good at all. All right. So as you can see right here, and that's the bell of the first period, what they end up doing is actually kind of just sharing electrons. All right, and the sharing of these two electrons right here will cause them to kind of stick together. All right, it's very simple. Just sharing electrons is a covalent bond. Now, it's important to note that the most common type of bond in macromolecules that cause them to stick together is going to be a covalent bond. All right, and so that's why I kind of introduce this, because it's important to understand how these molecules are being held together. All right. Another type of bond that might be interesting to you or come up in this unit is something called an ionic bond. And this one is not a sharing bond, but what actually happens is a donation. All right. So one atom will either give or one atom will receive an electron. So as you can see right here, this atom right here used to have this electron, but it actually donated it to this electron, this atom. All right, and the donation is actually what causes the attraction or the bonding together. So they will actually kind of stick together just because they've given away one and accepted one. All right, this covalent bond is a much stronger bond, very, very difficult to break. Like, for example, probably the table that your computer's on right now, that's covalently bonded together, and you obviously can't break your table unless you have a very, very strong force, and that's because the atoms in the table are bonded together by covalent bonds. Okay, an example of an ionic bond would be like salt. All right, salt is held together by an atom of sodium and an atom of chlorine. All right, and it's very easy to break it. All you got to do is just put it in water, and it dissolves and separates that bond. All right.